Welcome to học tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continuing with The Cat in the Box, a history of science in 100 experiments. Today we will read story number 93. Hôm nay chúng ta sẽ đọc truyện số 93, The Pacemaker of Ice Ages. Why does the Earth experience ice ages? It seems a natural question, but it turns out to have been phrased the wrong way around. The real puzzle is why, given the present-day arrangement of the continents, the Earth is not in a permanent ice age. The answer was suggested more than 100 years ago, but confirmed by experiment only in the mid-1970s. It was only in the 19th century that geologists realized that scratches and scars in the rocks and other evidence show that great ice sheets had once, and perhaps more than once, spread southward across Europe and North America from the polar regions. The Scot James Kroll in the 19th century and the Serbian Milutin Milankovic in the first half of the 20th century suggested that this might be related to the way the Earth tilts and wobbles as it orbits the Sun. But the idea, which became known as Milankovitch model, was not widely accepted. We experience seasons because the spinning Earth leans over at an angle of roughly 23.5 degrees from the vertical as it orbits around the Sun. This means that first one hemisphere leans towards the Sun, bringing summer, while at the same time the other hemisphere experiences winter. 6 months later, the situation is reversed. But this tilt is not constant. There is a wobble caused by the gravitational influence of the Sun and Moon, so that it changes from 21.8 degrees to 24.4 degrees over thousands of years. And there are other more subtle orbital variations. All this changes the amount of heat received from the Sun at different latitudes, the insolation in different seasons, although the amount of heat received by the whole planet over a whole year stays the same. Milankovitch calculated just how all these changes affected the insolation over hundreds of thousands of years, a remarkable tour de force in the days before electronic computers. It was natural to expect that ice ages would be at their peak when northern hemisphere winters were coldest, so ice could spread over the land. As Antarctica is always covered in ice and there is no nearby land to be affected, the southern hemisphere does not have such a powerful potential influence. But as geologists gather more data, they found exactly the opposite of the anticipated pattern. At times, when Milankovitch calculated that northern winters were coldest, ice ages went into retreat. The pattern that began to emerge was one in which, for several million years, during the Quaternary period of geological time, the Earth has been in the grip of an ice epoch, with glaciers spreading in full ice age conditions for roughly 100,000 years, and then retreating temporarily during intervals of roughly 10,000 years, known as interglacials. We are living in an interglacials. Then theorists realize what is going on, because the heat balance over the year is the same. Very cold northern winters go hand in hand with very hot northern summers. Interglacials occur only when the northern hemisphere summers are hot enough to melt the ice back toward the Arctic. This was fine in principle, but how could it be tested? The key experiment depended on the discovery that the Earth's magnetic field changes in strength and sometimes reverses direction, leaving a trace of fossil magnetism in the rocks. Using this fossil magnetism and evidence from other tracers, geologists were able to date the layers of sediments in cores drilled from the bed of Southern Ocean, centrally located between Africa, Australia, and Antarctica. These sediments are laid down as the years pass, with the youngest at the top and remain undisturbed on the seabed. By the mid-1970s, geologists had continuous record going back 500,000 years. These cores contain the remains of tiny sea creatures known as foraminifera, and the shells of these features contain atoms of oxygen that came from the water in which those creatures lived, which they used in building those shells. Oxygen in seawater comes in two varieties, isotopes, oxygen A16 and the heavier oxygen 18. Heavier molecules freeze more easily than light molecules. So during the Ice Age, there are proportionally fewer molecules of water containing oxygen 18 around for the foraminifera to absorb. So by measuring the proportion of oxygen 16 and oxygen 18 in organic remains of the deep sea sediments, climatologists were able to infer how the ice sheets had advanced and retreated over the millennia, with enough precision to test the predictions of the revised Milankovitch model. In 1976, Jim Hayes, John Imbrie, and Nick Shackleton published a paper in Science with the title Variation in the Earth's Orbit, Pacemaker of the Ice Ages, which pulled together all of this evidence and confirmed that interglacials occurred only when northern hemisphere summers were at their hottest. It is concluded, they said, that changes in the Earth's orbital geometry are the fundamental cause of the succession of quaternary ice ages. It was the moment when Milankovitch model came in from the cold and, having passed the experimental test, became a theory. Vocabulary section then. Phrase, continents, permanent, southward, wobble, variations, tilt, insolation, remarkable tour de force, Antarctica, retreat, retreating, intervals, interval, interglacials, fossil magnetism, undisturbed, foraminifera, climatologist, infer, Thank you so much for your time, and I will see you in the next story. Bye for now.